This shocked SpaceX engineers to their core. S-37's engine suddenly failed during what should have been a routine test, forcing an emergency Raptor replacement and a never-before-seen third static fire. Flight 10 pushed to August 28th. But the real question everyone's asking, is this the same fatal flaw that could doom all future Starship missions? Let's dive right in. Here's what really happened during those terrifying 48 hours when SpaceX engineers realized their worst nightmare was coming true. August 8th, 2024. 3:47 p.m. Central Time. S-37 sits on the test stand, its 6 Raptor engines ready for what everyone believed would be the final static fire before Flight 10. The countdown reaches 0, engines ignite, and for 30 seconds, everything looks perfect. Then engineer Sarah Chen notices something on her monitor that makes her blood run cold. "We have an anomaly in engine 2, she calls out. "Combustion chamber pressure is fluctuating beyond acceptable parameters." What happens next will haunt SpaceX for months. The engine isn't just underperforming, it's showing signs of what rocket engineers call hard start, an uncontrolled ignition sequence that can literally tear an engine apart from the inside. But here's the part that will shock you. This wasn't the first time they'd seen this pattern. Picture this scenario. You're building the most complex machine humanity has ever created. Every component costs millions. Every delay costs billions. And suddenly the heart of your entire system, the engine that's supposed to carry humans to Mars, starts showing signs of catastrophic failure. What do? SpaceX faced exactly this nightmare scenario. The Raptor vacuum engine showing the anomaly wasn't just any engine. It was part of a production batch that included engines already installed in multiple other Starships. The pressure in that room must have been crushing. Elon Musk himself was reportedly on site, watching telemetry data that suggested their entire Mars timeline could be in jeopardy. But then came the decision that stunned everyone. Instead of trying to work around the problem, instead of hoping it was a one-off glitch, SpaceX made the nuclear option, complete engine replacement. This meant tearing apart weeks of meticulous assembly work, risking contamination of other systems, and pushing Flight 10 into an uncertain timeline. Why would they take such a drastic step unless they knew something absolutely terrifying? Let me paint you a picture of what engine replacement actually means. This isn't like swapping out your car's spark plugs. We're talking about a 3,400-pound precision instrument that operates at temperatures hotter than the surface of the sun and pressures that could crush a submarine. Every connection point, every fuel line, every sensor cable has to be disconnected with surgical precision. One contaminating particle, one loose connection, one improper seal, and you're not just looking at another failed test. You're looking at a potential explosion that could level half of Starbase. The process is absolutely brutal. First, teams have to drain every drop of propellant from the system. We're talking about supercooled methane and oxygen that can freeze human tissue on contact. Then comes the scaffolding, massive metal structures that transform S-37 into something resembling a construction site more than a spacecraft. But here's what really shows how serious this problem was. SpaceX had to completely rebuild their test infrastructure. The pipes, the quick disconnect systems, the safety equipment, everything had to be disassembled and rebuilt from scratch. This level of work typically happens only when engineers discover something that could kill astronauts. Now here's where this story takes a terrifying turn. Sources close to the program have revealed that the S-37 engine issue wasn't isolated. Over the past 6 months, approximately 15 to 20% of all Raptor vacuum engines have shown similar combustion instability patterns during extended testing. Think about that for a moment. 1 in 5 engines has potential failure modes. This isn't just a manufacturing defect. This suggests a fundamental design issue with the Raptor vacuum variant. And here's the kicker. These engines are already installed in Starships sitting in production bays across Starbase. S-38, S-39, even the Block 2 vehicles under construction, how many of them are sitting on ticking time bombs? The implications are staggering. If SpaceX has to inspect and potentially replace engines across their entire fleet, we're not talking about delaying Flight 10 by a few weeks. We're talking about potentially grounding the entire Starship program for months. What SpaceX hasn't publicly disclosed is the activation of what insiders call Project Phoenix, an emergency protocol designed to identify and resolve systematic engine failures before they become public disasters. This isn't just about S37 anymore. Every Raptor engine destined for flight vehicles now undergoes what's essentially stress testing to failure. They're running engines through multiple startup sequences, varying power levels, and extended burn times that simulate worst-case mission scenarios. The results? Absolutely terrifying. According to sources, the testing has revealed that combustion instability can appear suddenly, even in engines that have passed previous tests. Worse, the failure mode seems to be triggered by specific operating conditions that are common during actual flights. In other words, engines that test perfectly on the ground could fail catastrophically in space. Let's talk about what this really means for SpaceX's grand vision. Elon Musk has promised humans on Mars by 2029. But if SpaceX can't trust their engines for basic Earth-to-orbit missions, how can they trust them for a 9-month journey to another planet? The math is absolutely brutal. Mars launch windows. Every 26 months, cargo missions needed, at least 10 before first human landing. Current mission success rate, questionable with engine reliability issues. Backup options if Starship fails. None miss the 2026 cargo window due to engine problems, and the first human Mars mission gets pushed to 2031 at the earliest. But here's what's really keeping NASA administrators awake at night. They've already committed to using Starship for Artemis moon missions. The idea of discovering a fundamental engine flaw after astronauts are already aboard is the stuff of space program nightmares. While SpaceX struggles with engine reliability, their competitors aren't standing still. Blue Origin's New Glenn is approaching its first launch with engines that, while less powerful, have undergone years of systematic testing. ULA's Vulcan, despite its own delays, has demonstrated consistent engine performance. The question isn't just whether SpaceX can fix their engine problem, it's whether they can fix it before customers lose confidence entirely. Amazon's Project Kuiper, multiple national security launches, even NASA's own missions. They all have backup options that don't involve Starship. If the engine reliability crisis continues, SpaceX could find themselves isolated just when they need customers most. Here's where the story gets even more complex. SpaceX is simultaneously dealing with the S37 crisis while developing Raptor FIM3, the next-generation engine that's supposed to solve all these problems. But what if the fundamental design philosophy is flawed? Raptor FI3 follows the same full-flow stage combustion cycle as its predecessors. If the combustion instability is inherent to this design when scaled to Starship's requirements, then V3 could amplify the problem rather than solve it. The new Block 2 Starships are designed around Raptor FI3. B-18, the first V3 booster, is already under construction. If SpaceX discovers that their engine architecture needs fundamental changes, every vehicle currently under construction could become obsolete overnight. We're talking about potentially billions of dollars in hardware that might never fly. The third static fire test for S37 isn't just about one engine or one Starship. It's about the credibility of SpaceX's entire approach to rapid rocket development. If the replacement engine shows similar problems, we're looking at a crisis that could reshape the entire space industry. NASA would be forced to reconsider their Artemis timeline. The Pentagon would have to evaluate their national security launch strategy. Commercial customers would start looking at alternatives they never considered before. But there's another possibility that's even more terrifying. What if the test succeeds, but the underlying problem remains hidden? Engines that pass ground tests but fail in flight. Missions that launch successfully but end in disaster months later during critical maneuvers. The kind of systematic failure that could set human spaceflight back by decades. Here's what SpaceX isn't telling you about the broader implications. The S37 delay doesn't just affect Flight 10. It's creating a traffic jam of epic proportions. S38 is waiting for test stand availability. B16 needs its flight termination system installed. The new BQD system for V3 vehicles is ready but can't be properly tested until the current crisis is resolved. Every day of delay multiplies exponentially. If S37's third test fails, SpaceX will be facing decisions that could fundamentally alter their entire development philosophy. Do they continue with Raptor 5.2 and accept lower performance? Do they skip to V3 and hope it solves problems they don't fully understand? Do they go back to the drawing board entirely? Behind all these technical challenges are the people working 80-hour weeks to solve problems that have never been solved before. The stress levels at Starbase are reportedly through the roof, with engineers pulling all-nighters to analyze data, redesign components, and prepare for tests that could make or break the entire program. These aren't just engineering problems. They're human dramas playing out in real time. Families separated by work demands. Engineers questioning whether their life's work will ever reach space. The psychological pressure of knowing that every decision could affect humanity's future as a spacefaring civilization. As we wait for S37's third static fire test, the entire space industry holds its breath. This isn't just about whether one engine will work. It's about whether SpaceX's entire philosophy of rapid iteration can overcome the fundamental challenges of rocket science. The test will either vindicate their approach or expose fatal flaws that have been hidden for years. If it succeeds, Flight 10 might launch in late August, and the program can begin to recover. If it fails, we could be looking at the most significant crisis in SpaceX's history, one that makes the early Falcon 1 failures look like minor setbacks. The stakes couldn't be higher. We're not just talking about one company's success or failure. We're talking about humanity's timeline for becoming a multi-planetary species, the future of space exploration, and the credibility of an entire generation of space entrepreneurs who promise to make the impossible routine. But there's one more revelation that changes everything we thought we knew about this crisis. So here we stand, watching SpaceX navigate their most critical test yet. S37's third static fire isn't just about fixing one engine. It's about proving whether humanity's Mars dreams are built on solid ground or wishful thinking. Think about it. Every great leap forward in human history came with moments like this. The Wright brothers facing skeptics. Apollo 11 with computer alarms screaming during lunar descent. SpaceX themselves after 3 Falcon 1 failures, betting everything on that fourth flight. The engine swap that shocked SpaceX engineers might be exactly what saves the entire program. Sometimes you have to break something completely to build it back stronger. What do you think? Is this crisis SpaceX's greatest challenge or their greatest opportunity? Will the engine reliability issues delay Mars colonization or force innovations that make it happen faster? Drop your thoughts below. I read every single comment, and some of your insights often become entire videos. Speaking of which, if you want the full deep dive into Raptor engine technology and why it's so revolutionary, that video is coming next week. Until then, keep looking up. The future of humanity might just depend on what happens next at Starbase. Engineers are panicking. The same killer engine that destroyed Flight 8 just struck Flight 10. Ship 37 emergency removal from the pad has everyone asking, is SpaceX hiding a fatal design flaw? 600 Raptor engines built, yet vacuum engines keep exploding in the same exact way. Flight 7, 8, 9, all killed by identical failures. But here's what's really shocking. Why does SpaceX keep using engines they know will fail? What aren't they telling us about Starship's biggest weakness? Let's dive right in. Picture this. August 1st, 4:30 p.m. Ship 37 has just completed what engineers called the most beautiful static fire we've ever seen. 6 Raptor engines roaring to life in perfect harmony. Every telemetry reading green. Champagne bottles popping in mission control. 48 hours later, emergency crews are ripping that same perfect engine out of the ship. What they found inside will haunt SpaceX for years. The vacuum Raptor showed signs of the exact same microfractures that killed Flight 8. Same location, same failure signature, same death sentence. But here's the part that'll make your blood run cold. SpaceX has known about this pattern for months. Let me show you something SpaceX never wanted you to see. NASA cameras just captured heavily damaged Raptor engines arriving at SpaceX's McGregor facility on flatbed trucks. These weren't just any engines. These were the mangled remains from Ship 36's spectacular explosion earlier this year. The timing is perfect. Ship 36 explodes. Ship 37 develops identical problems. Coincidence? Not a chance. But wait, it gets worse. Raptor engine serial number 580 was spotted at McGregor. That's the highest V2 serial number ever seen publicly, meaning SpaceX has built close to 600 Raptor 5.2 engines. 600 engines. Same failure mode. Every single time. You want to know why vacuum Raptors keep exploding? It's not what the textbooks tell you. These engines operate at 300 bar of pressure. That's 4,351 pounds per square inch, crushing down on every component. To put that in perspective, that's like having a full-grown elephant standing on every square inch of the engine. But pressure isn't the killer. Temperature is. Inside those vacuum engine bells, temperatures reach 3,000 degrees Celsius, hot enough to melt copper in milliseconds. The engine has to pump liquid methane at negative 162 degrees Celsius through turbopumps while combustion chambers burn at temperatures that would vaporize steel. It's like trying to keep an ice cube frozen while holding it inside a blast furnace. Here's what SpaceX engineers whisper about in the cafeteria. The vacuum Raptor design is fundamentally flawed. Remember those bird's nest of wires and cables we saw on early Raptors? Those weren't just for show. Each wire was a sensor, desperately trying to monitor temperatures and pressures that shouldn't exist in nature. SpaceX has been at war with these sensors since day one. They recently lost a Falcon 9, their first failure in over 300 launches, because of a loose sensor line. One wire brought down their most reliable rocket. Now imagine 33 engines, each with hundreds of sensors, all trying to survive conditions that would make the surface of Venus look comfortable. But Ship 37's perfect static fire wasn't perfect at all. It was a carefully orchestrated lie. Here's what really happened. During the 6-engine test, telemetry showed micro vibrations in Raptor vacuum engine number 4. Not enough to abort the test, but enough to plant seeds of doubt in engineers' minds. Post-fire analysis revealed hairline cracks in the engine bell. The exact same cracks that have